Yes, good afternoon, all of you. Let's start our today's session. So, all of you are supposed to start the wake up. Okay. Today, in today's lab, actually, we will be exploring the Weka tool, and we will have more detail, or you can say, example on classification and clustering and all those things. So, today we will learn various types of classification algorithm. Okay, means I will show you that how we can use different kind of classification algorithm with the data set, and how we can explore the result whatever we have received from the output of algorithm. So let me share my screen so you can have idea. All of you be ready with your system. Means keep or open your Weka, and then we will load the data set into our environment. So then I will show you that how to move forward. Okay, so let me share my screen with you so you can have idea that what we are going to do today. So we will be starting with we will be starting with the loading the data set into the environment. Okay, so let's load any environment into load any data set into our environment. So let me open the file again, program file weka data. Let's open any data set. For example, let's open diabetes. Okay, so this is the data set. Now how to use the various types of data sets. Okay, and means how we can prepare the model, how we can use it for future reference. So that we will be discussing today. uh, Here you can see, here we are having various you can say tabs. So you can we can perform different tasks like classification, clustering, rule association mining, attribute selection, principal component analysis. Okay, let's say if you want to select certain number of attribute, you want to remove certain attribute from the data set for the training. Okay, then that analysis can be performed over here. Select attribute. So then at last there is visualize. Okay, so visualization will show you that how these attributes are related. For example, if you click on the age, okay, then it will enlarge it and it will show you the graph. Let me show you some condition where actually we can represent some correlation between the attributes. Okay, and mm, just a minute. Let me present that window. Okay, now this window is visible to you, right? So this is the graph between, let's say here at present we are in visualization part, and this is the graph between mass and skin. Okay, so can we say, is there any relationship between mass and skin based on this scatter plot?
Doesn't seem like so.
No, is it like that?
Sir, start
Isn't
setting
it?
better.
Yes, but from where? From this point onwards. Okay, from this point onwards, they are, we can say, not completely linearly dependent, but they are, you can say, almost partially linearly dependent. Why? Because as you can see, all the value of x-axis increases with that. value of y-axis will also increase. Okay. Now, if we add some random noise into this, then you can see. So we won't be discussing what is this rectangle, polygon, polyline. Okay, but we can have some interrelation, correlation analysis. Okay, with the help of this. So that is a visualization tab. Now let's get back to the Veka Explorer. So in Veka Explorer, today we will discuss classification. Okay, how to do the classification, how why these kind of tools are useful. So in this tool is developed by University of Pekatio. Okay, and they have implemented all the you can say not all but popular classification algorithm into this. So if you will go to this part, okay, then here in classifier, you will get different kind of classifier. Like let's say if you go to the base means of a probability base classifier, okay, then this is the Navy base, for example. This is the most popular. This one we are going to discuss in our lecture session as well. Okay, we have selected this one. We will keep this as it is. Okay, and then we will click on start. Here you can see they have given the name of the data set, then attribute, okay, and then they have started the testing. Okay, so at the end, it has shown that out of 100 percentage, 76 percentage objects are classified correctly, while 23 percentage objects are not classified currently. Okay, so accuracy is 76 percentage. Another measure to you can say define the performance of um, this classification algorithm is confusion matrix. Okay, so confusion matrix will give you idea that how much algorithm is capable to detect the positive class or negative class. What is the learning fold? Okay, in short means in short it is detecting positive class object as a negative class. Okay, or negative class object as a positive class. Now, before discussing all these things in detail, okay, can anyone tell me what is classification? Very simple and key question. Nobody asked me, so I thought let me ask you people. What is classification?
They're grouping things which have
It's
common
the
something
same
in
type
common.
of, yes, sir. Grouping same type of elements together.
Okay. Can anybody give me example of classification where you could, in routine in your routine life? Can anyone give me any example of classification? Anyone? You people are doing it lots of time. Yes?
File system in Windows.
Not exactly.
Sir, Amazon carts and all. Searching on Amazon.
Yes, searching on Amazon. Okay, so let's say if you are searching for some thing, some item on Amazon, okay, you will come across any product. Then what you will do? You will check whether that product. Let's say you are looking for RAM, okay, on Amazon. Then you are coming across you can say one product, for example backpack, okay, and laptop. Now what you are looking for, you are actually looking for RAM, okay, and what it is showing, it is showing you backpack. Okay, so how you come to know that this is not in your area of interest by classification? Okay, but classification doesn't means or you will always do the classification in that way only. Okay, most of time the difference between classification and clustering is that in classification you have idea about the label, okay, but in case of clustering you don't have label, okay, but based on the similarity, based on the characteristics, you will you can say you will group that in clustering, okay, while in classification based on your past experience you will label them. So, in case of classification, we have to train the model, and then based on the training, uh, uh, we will prepare the model, okay, and then we will use that model for testing purpose. So, let's start with that classification. Okay, so here there are various approach in classification, like Navy Bayes is one of the example. So this approach is based on the probability theory. Okay, Navy Bayes theorem works on the probability. So if you want to configure any algorithm, any training algorithm, okay, in Veka, okay, then here you have to simply click on it. It will show you the dialog box, okay, and then it will uh, allow you to configure it. Okay, if you want to know the detail, if you want to know the detail about it, okay, you can just click on more, okay, it will show you the detail that navy based classifier using estimator classes, numeric estimator, okay, who has implemented this algorithm when it was proposed, for example, in 1995. They have given some reference to this. Okay, option. They have also given the option. So, if you want to know the detail about this, then you can click on more. If you will click on capability, then it will give you data that this algorithm is capable to work with binary classification. It is also able to handle the missing class values and nominal class. Nominal class means uh, non-numeric class. Okay, attribute can be binary attribute, empty nominal attribute, missing value, nominal attribute. So this can work with categorical data as well as numerical data. Okay, so this is the capability. So for each algorithm, there will be some configuration parameter, okay, as well as some detail and the capability. Capability will give you idea that which kind of data set you can use. If you will select any, let's say, naive-Bayes multinomial, okay, and if you will start with it, then you see in this case we are getting only 59 percentage, 60 percentage accuracy. In previous case, in simple naive-Bayes, we are getting 76. If we go with some function like let's say SMO, okay, this is the support vector machine, okay, so and if you will click on it, start, okay, then here you can see we are getting 77 percentage accuracy, previously 76, and here we are getting 77. So the performance of algorithm, it is not fixed. Okay, so it is not like that. This algorithm will give this kind of efficiency in all the cases. So the data, the training data which you are giving as input, that will make really uh, that will make sense. Okay. For example, here we have taken cross validation, but instead of that, let's say we will divide our data set into two parts. 66 percentage we will use for training, and 33 percentage we will use for testing. And then if I will click OK, then here you can see accuracy is increased by 79. Okay, so previously it was 77, now it is 79. Okay, if you will click on this, then they will allow you to configure it. Okay, for example, in support vector machine, we can configure the kernel. Okay, so in kernel, let's bring data to higher dimension. Okay, by raising the power exponent. So 3.0. Let's click on OK, then start. Okay, here you can see previously accuracy was only 79 percentage, but as we bring data into higher dimension, okay, so it become more separable. So accuracy is increased. Okay, still here we are having various options. Okay, for example, there is polynomial kernel. Instead of polynomial kernel, let's say RBF kernel. We are taking RBF kernel. Okay, and they have given two property gamma. and cache size. Okay, so if you will click on capability, then binary class, it will tell us that which type of classification we can use. Okay, and this is how it will be evaluated. Gamma raised to power. So if you want to increase the gamma, let's say 0.01 to zero point 0.5. Okay, we will click OK, OK, then start. Then here you can see we are getting 68% accuracy. So what I want to say, the data set is same, okay? But if we change the algorithm or if we change the tuning parameter of the algorithm, okay, it will affect the performance of the uh, algorithm. Okay, so before before going with training, okay, you should select that which kind of algorithm you are planning to use with, because let's say that in real time scenario the data sets are very large. Okay, they are very huge. Rather than large, we can say it is they are very huge. So, what will happen if you will start training, okay, and then later on, if you find out or you came to know that no, this algorithm is not good for this, okay, then you have to stop the training, you have to start it again. So, this may lead to the problem. So, that's it from my side. What actually I want you people to do in today's session. So in today's session, I want you people to try the different kind of data set in Weka. Okay, and then you explore the various data set into this. Uh, Let me show you one more example. Let's open a data set. Here you can see we are having one data set. mm, Reuters con test and trend. Okay, so what is meaning of this? Meaning of this is testing data set, means once the model is prepared. Okay, and this is training data set. Okay, so for training purpose, let's open it. Okay, now we have opened it, and we are having only uh, class. Okay, only two attributes are there. Okay, and supply test set, here we will select the open file. Okay, and test open. Okay, close, start. Okay, so it is showing error because of some format. Okay, but in case you are having training and testing data set separately, okay, then you can specify, you can supply those data. Okay, and if you don't want to do anything, okay, you want to simply use the whatever data set you have already downloaded. Okay, for example, grain test. Okay, then in this also they've given only two attribute, hypothyroid. Okay, here we are having 30 number of attributes. So the data set using which we have prepared the model. Okay, using that same data set, if you want to train, if you want to test, okay, then here we can say that in test option use the training set. So if you will click on start, okay, and then this bird is moving, that means process is going on. So here we are getting accuracy up to 92%. Here model whatever we have prepared in training, that we are testing using that same data set. Okay, this cross validation means k-fold cross validation. All these things we will discuss in theory. Okay, that what is the meaning of this and how it can be implemented. So all of you are clear with this, that how you have to do all this thing. Okay, you can go to the associate and a priori. Okay, for example, filter associator, you will click on start. Okay, and let's see. Okay, there is error log, there is some error. So let us select some good data set. Here we will go, there is a weather forecast. Okay, weather nominal. We will go with weather nominal. We will go to the associate. We will select the a priori. We will click on start. Okay, so here you can see they have given us the rule. Okay, if outlook is overcast, okay, then play is possible. If temperature is cool, then the humidity will be normal. If humidity is normal and environment or weather is not windy, then play is possible. Okay, if outlook is sunny, okay, and play is not possible, then the proper humidity is high. So what this associate will do, rule association mining, it will give you a set of rules. Okay, that from this data set we are having this set of rules that we can use. Sometimes not all the rules are all the rules are useful. Sometimes you have to filter it manually, and then useful rule you can use in expert system. So some you can have some numerical data set. Let's say whether numeric. Let's click on open. Okay, let's go to the associate whether they are allowing us. No, they are not allowing. Okay, but in case of this, they are not giving. It is showing their C error log. So it is showing error. Veka association type a priori cannot handle the numeric attribute. Okay, so it is having issue with numeric. So while you are working with association, rule association mining, you must have to pass only and only you can say categorical data, not numeric. Okay, so if we go with iris and then we will go to the associate, then again this will give us error. Okay, because here also we must have some okay numerical values. So if you want to go with the association mining, then we must have to provide them categorical data. We cannot provide them the numerical data. Okay, contact lens also, it is also a numeric data. So it will not allow us. You can go to the cluster and then you can select different algorithm like cobweb is there, then hierarchical clustering is there, chameleon, db scan. So lots of options they have given. In classification, if I give you just overview of this classifier, whatever they have implemented, then here you will find navy base means probability based classifier. Okay, so for probability based classifier means in that case we will be using probability theory. We will be using probability theory to predict the classification. Okay, so that is though all those belongs to the base. Then function. Okay, so in function we will have statistics base or you can say mathematics base a classification algorithm. Like let's say Gaussian process is there, linear regression is there, logistic regression is there, multi-layer perceptron. This is neural network. Okay, so if you will click on this, you will click on start. Okay, then you can see we are having 100% accuracy. If you will right click on it and let's see if they view in main window. No, they allow us to view in separate window. No, they allow us to visualize the model. Mm, visualize cost benefit analysis. No, in tree they will allow us, but margin curve. Okay, this is the margin curve, but they are not allowing us to visualize it. But somehow in one or another way they will allow us. So I think in MATLAB you can visualize the neural network. Okay, so that is a multi-layer perceptron. Then SGD. Okay, so SGD is stochastic gradient descent. So this is part of a gradient descent learning method. Okay, regression, then text, then simple linear regression, simple logistic regression, SMO. This is based on support vector machine. SMO regression, okay, and then what did perceptron. So different algorithms they have given. Okay, you can have detail about it. Then another class of learning, that is lazy learner. Okay, so lazy learner means these are the kind of these are the kind of algorithm where there is not any where there is not any need of training. Okay, without training you can use this you can use any algorithm. For example, IBK. It is also known as K nearest neighbor. Okay, so if you will click on it, then if you will start, then you can see here it is giving 100% result with the contact lens. So lazy learner, it is a you can say type of algorithm where there is no need of training. Okay, and what is the downside? What is the advantage of this? Advantage is that there is no training. There is no need of training. Okay, without training we can use it. And what is the downside of it? Okay, downside of it that it will take too much time to give the result in form of prediction. So each one is having their own advantages and disadvantages. So depending on your requirement, you can use it. Then there is a meta learner. So ADA boost is there, begging is there, classification via regression. Okay, filter classifier, logit boost. So multi-class classifier. Lots of meta classifier they have given. Okay, then the miscellaneous in miscellaneous input map classifier. So if you want to provide your own classifier, then you can specify over here. Then rules based. So these are the decision table, decision tree. So decision tree based classifier. If you want to use that, that also you can use. Okay, and next is tree. So this is in tree J40. Let's click on J48. Click on start. Okay, and here you can see accuracy is 91%. Right click on it and you can visualize the tree. Okay, so if you will click on visualize the tree, okay, then it will they will show you the tree. Okay, the tree will look like. Let me show you so you can have idea that actually how tree look like. Okay, so this is how tree look like. Okay, this is how tree they have prepared. Clear? So this is the tree which they have prepared using the algorithm. Now, if let's say sometimes what will happen if there are very large number of attributes, then some of the branch will be merged. Okay, and then it will be displayed. And if you will double click on any node, then whatever subtrees are there, it will be displayed to you. Okay, but at present in this scenario we don't have any tree, so that's why it is showing that there is no available instance data for this node. Okay, so uh, if there are any pruned branch or summarized branch, okay, then it will show you that data. So what is your task? What you people are supposed to do now? Okay, you people just go to the Kaggle website. Okay, and in Kaggle website you will find the data set for the corona. Okay, so you just download that data set. Okay, you just try any file algorithm on that data set and store the result. Okay, get the result and just try to observe the things whatever you are getting in output. Clear?
Excuse me, sir.
Yes.
कोरोना डेटा सेट लैब में आपने करने बोला था वही है ना? 831 और 832 रो हमने निकाली थी उसमें से।
Your voice is breaking. Hello.
सर ही वाज सेइंग जो आपने लास्ट टाइम जो दिया था ना लैब में वही ना कोरोना वाला।
Wait. Okay. You will find multiple data sets for corona. Let me go to the Kaggle website and let me find the data. in data, that was corona vaccination data. Okay, and yes, there is a COVID-19 open research data set. They have given 17 tasks. Okay, and they have given that in CSV format. Okay, so you can have you just download. Okay, that is very big data. That is 7 GB data. So let's select any small. Let's go to the classification, and in classification, are tweets really effective? So they have given one Twitter data set. Okay, that is
Sir,
also.
your screen is वैका ही दिख रहा है सर
Huh?
वैका ही दिख रहा है सर
No, I know. Actually, I have not shared my screen.
ओके सर
In short, what I want you people to do, you just go to the Kaggle, you download any small data set, okay, and then just try to load it into the wake up, okay, and then you try with different algorithms which I told you, okay. So this is the screen. Twitter, it is a bit larger data set. Okay, so let's go to the data on classification. We will get yes here heart disease. I think this we have already used in previous semester in Python. Okay, so job change of the data scientist. Okay, HR analytics. So this is also data set. Download it. Okay, and it is in CSV format. Okay, so they have separate training and testing data set. So all of you do one thing, you download this HR analytics job change of the data scientist, okay, and then uh, try the various algorithms which we have discussed. Okay, all of you are clear with your task, what you are supposed to do? Yes, all of you are clear with the task, what you are
Yes.
supposed to do? Okay, so please start working on it. So please start working on it.
Hello, sir.
Yes, yes, Shema.
Hello, sir.
Yes,
Can I share my screen for a while, sir?
yeah, sure, why not?
Okay. Is it visible, sir?
Yes.
Sir, why didn't I get option for start, sir, here?
Here you can see, you just read the bottommost part of your, not bottommost part.
Here, sir. Total number of
Uh,
instant.
No, 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 not that. Status. You just read the status. Here, below. Bottom left corner.
Uh, Program task first.
Okay. Okay, so you just close it and open it again. Here you have to select, just go to the classifier. Okay, select all. First of all, go to the pre-process, not there. Go to pre-process, select all, not there. You simply click on all. Okay, that's it. Okay, just go to the classify. Okay, just click on choose. Go to the function. Base will not work. Base will ask for. Okay, no, none of them are unable. So just explore lazy learner. Okay, just click it. No, no. So just still scroll down.
Mega.
Yeah, click on meta.
Here is most.
Select any
Which
miscellaneous rules. You just try to explore it.
Okay, sir.
Okay, and if you are not able to, let me tell you that if you are not able to use this algorithm, if you are not able to use algorithm with this data set, then you can try with some another data set.
Okay, sir.
Okay, got it.
Yes, sir. Okay, sir.
हेलो सर।
Yes.
सर मैंने एक डेटा सेट डाउनलोड किया, उसमें BCD 000 आ रहे हैं कंफ्यूजन मैट्रिक्स में।
Confusion matrix में 000 आ रहा है. Please share your screen so I can
यस
help you.
सर। सर एक मिनट, माइक म्यूट कर रहा हूँ।
Yes. Okay, no, it is not get. You are not your algorithm. You are not getting 000. You see, your algorithm is diverted toward class A. It is detecting all the object to class A, graduate. Your algorithm is not able to detect the high school, masters, PhD, and primary. Got it?
यस सर, गॉट इट।
Huh?
यस सर, समझ गया।
Your voice is breaking. Okay, so let's conclude our today's lab session here.